to talk about in this section, we're a little bit out of order because I did section 5 first. I'm coming back to do the last couple things out of chapter 4 that we haven't covered. So L'Hopital's rule is something that we can use when we have limits that we would not otherwise be able to evaluate. So, for instance, if I had this function, the natural log of x over x minus 1. Okay, can we agree that you can't just, if I were doing the limit as you approach 1, can you just plug in a 1 there?
No, can't do that.
The natural log of 1, do you guys remember what the natural log of 1 is?
Oh yeah, I do.
X over.
No, it's
Yeah,
just
1 over.
Not the derivative. I just want to know what is the natural log of 1?
Oh,
Oh.
Like, natural log
wait.
Means
It's e.
e to what power?
Zero.
Zero. Oh my gosh, it's zero.
Zero.
Goodness gracious.
So,
Oh my goodness.
if you put a 1 in on top, you get 0. If you put a 1 in on the bottom, you get 0. So we know what 0 divided by 0 is. No, we can't divide by 0. Now, we have had limits like this in the past where you had 0 on the bottom, and we had different techniques we would do to try to get 0 off the bottom. Things like factoring and reducing. Am I going to be able to factor and reduce? No. Things like multiplying by a conjugate. Can I multiply by a conjugate here? No. Trying to get sine x over x. Is that an option here? No. So none of the things that we've done in the past would be relevant here. They wouldn't help me evaluate this limit. So, we can't just evaluate it. But in general, this is called an indeterminate form of type 0 over 0. We are going to have a list of different indeterminates in this section. All different things that we can't simplify. So if we have 0 divided by 0, we do not know what that turns into. It is an indeterminate form. What we are going to do in this case is L'Hopital's rule. So, L'Hopital's rule says if you have differentiable functions, what does it mean to be a differentiable function?
You can find the difference.
Derivative.
Oh, yep.
Differentiable, there's a derivative. And the derivative at the bottom isn't 0. Then this statement is true, which is huge. The limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. I am not, unless you guys are just really offended by that, I wasn't going to take the time to show why this is true. Can you just trust me? It's a very complicated, it's not a simple light bulb type.
That's not a simple
It is
light.
a little more complex. But it has to be of a certain form for this to work. It has to be of an indeterminate form, 0 over 0, or infinity over infinity. And it can also be like positive infinity over negative infinity or something like that. So if you have 0 over 0 or infinity over infinity, that is a situation where this will hold. That, the limit is the same as if you do the derivative of the top and derivative of the bottom. Notice, it's not the derivative of the quotient, so we're not doing quotient rule. It's just derivative of the top function divided by derivative of the bottom function.
So could this end up that we have a fraction on the top and the bottom?
Mm-hmm.
That's not very pretty.
Yes.
Can it be like, if it's infinity or infinity, does it have to be negative and negative, or can it be positive?
It can be different combinations of signs.
Well, we have
We
to
can
get
make
the
some up.
radicals
Mhm.
off the bottom.
For final answers, yes.
Dang.
What kind of question was that?
Well, I'm saying like if it gets very, very ugly.
I'm gonna have multiple fractions and a fraction, and she's gonna be like, oh, you got it. Gotta fix it.
Okay. So, for this particular problem, we already agreed that right now, if I just plug it in, I get 0 over 0. That's the first step. You have to make sure it's one of the types where it works. Okay? So, because it's an indeterminate form, I'm going to do L'Hopital's rule. Now, what I like to do is I write LH over the top of my equal sign. That tells me that I did L'Hopital's rule there. And it also, when I'm checking your work, I can tell where you did L'Hopital's rule and how you're getting to your
And I
answers.
did
I
a
know
capital LH.
I know we said this gets 0, 0, but I don't, but like we figured it out, but I don't understand how like 0 minus 1 is 0.
Because we're approaching 1.
Got it. Yes, ma'am.
So, L'Hopital's rule says you can do the same limit, but we're going to do derivative of the top divided by derivative of bottom. What is the derivative of natural log x?
1 over x times 1.
Just 1 over x. Over, what's the derivative of the bottom?
4.
So this is limit x approaches 1 of 1 over x. Can we figure out what that is?
Yeah.
Yeah, we can plug our 1 in now and we get
1.
1. So, because it was an indeterminate form, I can do my L'Hopital's and I evaluate my limit.
That was much easier than I
Wow.
Yeah, because you're not doing a full quotient rule,
Yeah,
they're much nicer. They don't get uglier.
that's very kind.
Isn't it?
Doing
Oh.
is doing the derivative. Oh, never mind. The derivative of e to the x is just e to the x. Yeah,
Mhm.
never mind.
Mhm.
Other questions there?
I'm only gonna draw my L's like this with the.
So like we don't actually have to like compare the two, like set them equal really to one another, we're kind of just turning it into.
For now.
I like pick up new handwriting stuff from doing math. Like my F's are curly now because I do curly F's in here, and my mom hates it. But now I'll have the curly ones.
Alright, if I look at this one, e to the infinity, what's that going to turn into?
Infinity.
Because e is a number, so if you take it to a bigger and bigger and bigger power, you're getting a bigger answer. Okay, infinity squared is going to infinity. So infinity over infinity, is that one of the situations where we can do it?
Yes.
Yes. So I'm going to do L'Hopital's. Please identify when you do it. So we have x approaches infinity. Okay, derivative of e to the x is
E to the x.
over. What's the derivative of x squared? So now, what's e to the infinity? What's 2 times infinity? So what do you think that means? Do we know what infinity over infinity is?
I don't know.
But if it's 0 over 0 or infinity over infinity, what do we do?
We have to do another derivative. Yeah.
Oh, whoa.
L'Hopital's the second time because it's still the indeterminate form.
Is there a way to do the note that you did it a second time?
You just write it
again.
again.
Just
Okay.
keep writing.
Derivative of e to the x is still e to the x. What's the derivative of 2x?
Hmm.
Okay, so now we have infinity over 2. Can you tell me what that goes to?
No.
You can't?
Infinity.
Oh, 0. 1.
Wait. We have 2 pizzas.
Well, infinity.
And we split them up in an infinity amount of times. How
Okay.
many pieces?
No,
do we
No,
have?
you're doing it backwards. We have infinite pizzas. You have 2 people, okay? And they have 10 pizzas, or 100 pizzas, or 1,000 pizzas. The number of pizzas is getting bigger and bigger. So what's happening to the amount of pizza each person gets? It's going.
Bigger and bigger. It's infinity. Yeah.
The infinities just like confuse me sometimes. They just. I start
So
thinking about pizzas.
another way to think
and
about it is just plug in numbers. X is getting bigger and bigger.
Play
So 10
infinity
over
like
2, 100 over 2,
play
1,000
infinity like
over
an
2.
X.
Wow.
And just think what's happening to your answer.
Well, I think the pizza joke just got a little out of hand in my brain, and now it doesn't work as like right like it should.
It was a good.
If the pizza's on the top, it's getting bigger. If the pizza's on the bottom, it's getting smaller. Unless there's like a fraction on the bottom.
And then it was, yeah,
All right,
kind of crazy.
let's take a look at this one. So we have.
Not happy.
Okay. Natural log of infinity.
Natural law would be infinity over x.
Okay, I'm just asking you the natural log as x is getting bigger and bigger. What is that heading to?
E to the blank equals infinity.
It's just a really bigger and bigger number. Or if you think about like a natural log graph, it's like this. So as it gets bigger, as x is getting bigger, your y is getting bigger. Okay, what's the cube root of a really big number?
Really big number.
Also really.
So infinity over infinity tells me we can do
Hospital. Oh, Opital. Sorry.
OP.
L'Hopital. So label your LH. What is the derivative of natural log x?
1 over x.
Okay, the cube root, keep in mind, that's like x to the 1/3. So how do we rewrite that?
1/3 x to the negative 2/3.
With
I would recommend cleaning this up a
Oh
little
my
bit.
gosh, I keep forgetting my limits.
Wait, is that 2/3 power or minus?
Negative
Negative
2/3,
2/3.
because you subtract one
So
from the
then
power.
we make another fraction.
Okay, so if we think about what this means, 1/3 x to the negative 2/3, that's like saying 1/3x to the 2/3 power. But again, I don't want to just try to evaluate right here, because if I do, 1/infinity is going to 0, so I have 0/0, which tells me L'Hopital's. But it's going to keep getting uglier in this situation.
Do we multiply by the bottom to like,
How do we divide fractions?
we skip the multiply?
Flip and multiply. Oh, this one looks indecent.
That's not, I don't think that's the word you mean.
No, it is.
Okay. So when we're doing this, you subtract those exponents. So it's
Subtract the
Oh,
exponents.
they're on top and bottom.
That's
Oh,
what
oh, 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 okay.
So-
X to the 1/3 on the bottom.
3/x to the 1/3.
Okay. So if you have
Oh my gosh,
3 over a really big number, what's that going to go to?
0. Because we get less and less pizza. Yay.
So simplifying can be helpful.
I should write out that one step that I skipped. I just know myself that I'm gonna look back at this and not. Thank you, I love you.
She says that for now.
No,
We
that
won't.
was a very
Just wait for
sincere.
next month.
That was a very sincere Miss Beckles no.
Yeah. It wasn't like my.
This wasn't like
We
the
gotta transform
not
it before we
yet.
even
Like,
do
did you like your canopper?
That's what we did.
Oh, I.
The XYZ graph of the derivative. You'll have it going in like a wave all the way around.
So. Alright. Let's look at another.
What the heck?
Like
Sorry.
right now.
Tangent of 0 is tan 0. Right? Because it's time.
How sure am I, Grant? I'm like 100.
You got pumped up in the office this morning.
But,
You got upset.
Great.
dude,
I hate
Grant's addicted to that cough syrup medicine.
I buy like the.
Grant's on the lean.
You like mixing it with Sprite now?
Alright, let's do a problem here.
Tangent of 0 is 0, right?
I can bring you
That thing.
I can bring you more tomorrow. I'm probably gonna need some myself.
So, tangent is 0.
Tangent is.
So you have to think sine over cosine, square root of the top over square root of the bottom. So we get 0 over 2, which is 0. Minus 0 is
0.
0.
over. 0 cubed is.
0.
So 0 over 0 is an indeterminate form. So we can do
Look at dog.
L'Hopital's. Okay.
Are you gonna trick us at the one that?
Are you ever gonna check this?
Maybe the next example. Derivative of tangent is.
Sine. Wait.
Secant square
Secant
tangent.
square
Oh my
tangent.
goodness.
Secant square
And
tangent.
secant
Secant square
square
You
tangent.
people all fail. Derivative of tangent is secant squared.
Oh.
Yeah.
Derivative
Yay!
of tangent is secant tangent.
Oh, that's the one I was
Oh, we're gonna have a pop quiz tomorrow.
No.
Derivatives of trig
Whoa,
functions.
whoa. I'm barely scraping
Yeah,
by
no.
with my
Alright.
teeth
thinking of.
in this
I'm locked in.
class.
I'll do the full
Derivative
proof.
of x
1.
over derivative of x cubed.
3x squared.
Have you ever done a pop quiz? Like,
Can you do
It's not a pop quiz if she threatens it the day before, though.
That's
we've
true.
done a pop quiz.
That's, you gotta do it again because it's still 0.
Okay, so if we look at this, secant squared. So secant of 0. So if you think about cosine of 0 is 1. So secant would be 1.
1
So 1 minus 1 is 0.
over 0. It's still
Gotta do it again.
Oh, man.
Okay. So that means we're doing L'Hopital's again. So let's label it again. Alright, so when you're doing the derivative of secant squared, remember that's the same thing as saying secant of x all squared. So we have to bring down the 2.
Oh, secant.
Inside stays the same. subtract 1 from the power, so it's just secant, times derivative of the inside.
The derivative of secant is secant and cosine? Tangent, darn it.
Oh, you're failing.
Minus derivative of 1 is just 0. Over derivative of 3x squared, 6x. So,
Holy goodness.
Wow, this
Is the
looks
bottom
beautiful.
still
But we have to do the
zero?
third
we get 2 secant squared x tangent x over 6x. So if you are looking at this, yes, it is still 0 over 0. So you can choose to do L'Hopital's again. May or may not be the best option. The bottom will be nice. The top, we're going to have some ugliness because it'll be product rule and chain rule. You can also, at any point, try to simplify things. Now, it may or may not completely help, but if nothing else, if we simplify it, we'll have something nicer to do the derivative of, right? So do you want to see if this would simplify at all?
Yes, please.
Yep. Secant
The way you're
is
saying that
1
makes
over
it feel like
sine.
it might.
Tangent is
Okay.
sine
Doesn't
over
make it so
cosine.
awful.
So one
So-
of the secants cancels. Not. Wait.
Well, it's 1/3. I know that much.
Shit.
So we have 1/3. We have a secant squared, and I'm going to,
Does smell like a butter.
okay, we can think of that as tangent x over x. Now, there's other stuff we could do at this point. If you wanted, you could change tangent into sines and cosines, and that would help a little bit, perhaps. If you remember some of our other rules that are still true, those might come in handy. So there's a lot of different options here. We can also think about, okay, the 1/3 would just come out, right? You can break these limits up. Haven't we said that if you have the limit of things being multiplied, you can do individual limits?
Oh, yeah.
Yeah, it was.
I remember that, of course.
Not necessarily the only way to do this, but as x approaches 0, what's the limit of secant squared? Secant of 0 is
Cosine 1.
1. So that's a nice one. So then our only problem is really here.
So we do L'Hopital's on just that piece.
So
Wait.
My words are gonna be all over the place. I'm so sorry.
Can you explain the secant squared?
So, think about our answer. At 0, cosine is the square root of the bottom over 2. So square root of 4 over 2 is 2 over 2, so 1. So then secant is the reciprocal of 1, so it's 1.
How did the 1/3 get out?
We had limit laws at the very beginning. If it's just a coefficient, you can pull it out in front. Because there's no x's in it, so you don't have to worry about that.
Hey, I know the derivative of tangent now, by the
So,
way.
if we do L'Hopital's one final time, we get 1/3 limit, because x approaches 0. Derivative of tangent is
Secant
squared over derivative of x is 1. This finally turned into something nice. Secant of 0 is 1, squared is still 1, so 1/3 times 1 is 1/3. Now, did we have to do it that way? No. We could have tried L'Hopital's right up here. It would have been uglier, but we could have gotten there from that point. You might have chose to simplify it a different way at this point if you went into sines and cosines. So we have a lot of different options here. Essentially, all of your limit rules still hold. Anything that we have learned to be true is still true. L'Hopital's is just another option that we have.
Read page 3.
Alright, so the limit as we are approaching pi from the left,
Hang on, question. Is that a -1 on the bottom, or is that just like a weird line?
it's pi from the left.
Oh,
Pi
okay,
from the-
gotcha.
We can do sides.
I forgot
Remember
about
our
that.
one-sided limits?
I
Yeah,
forgot.
no,
I
I remember
forgot.
that. I mean,
I
it
didn't
is.
remember.
So let's figure this out.
Sine of pi is 180.
So, yeah.
So
If
that'll
you think
be
back to
zero.
your unit circle days, this is the point negative 1, 0.
So it's
So
0.
it's 0 over 0, basically.
Is it?
Wait, no, cosine of wait,
Cosine of pi is negative 1. 1 minus negative 1.
is 2.
Do I need L'Hopital's?
No.
Remember how she said,
0 over 2 is 0. So you might have some limits that you can still do. L'Hopital's will only lead you to the right answer if it's one of those indeterminate forms, 0, 0, or infinity over infinity. So you need to make sure you're verifying it at the beginning. Okay?
I forgot you said.
Maybe on the next one.
Yeah.
So how did we find like the limit and stuff when it didn't work before?
The
Was
rule.
that we had ones that didn't work, or did we just say the limit does not exist?
Yeah, we'll just set the limit to
Mhm.
sizes.
The limit does exist.
Okay. I'm going to stop here for today.
You should like throw one at me.
Grant, this is like the equivalent of a contract.
I want you guys to do, we're going to do some book problems.
Together?
Together?
Wait, catch it in your mouth.